Hi, these are the lesson activities for sections 4.3 and 4.4 for Math 117, mathematical problem solving. Okay, number 1, we're going to use Adams' method to apportion the seats of Parador's Congress. For this one, I have given you a divisor that works rather than making you find one. Okay, so we have all of the populations for each of the 6 states and the total. And then we calculate the standard quotas, which, if you remember how to do this from when we did Hamilton's method, you start by calculating a standard divisor, which was the total population, 12,500,000, divided by 250 seats, came out to 50,000. Then we divided each state's population by 50,000 people per seat, and get the standard quotas, exact fair shares. Adds up to 250. Okay, now Adams' method says round everything up. Just always go up to the next whole number. So we've got 33, 139, 4, 42, 14, and 20. And when we add these up, we get 252, which is too big, right? We only have 250 seats to give out. When the sum, T, is too big, we make the divisor bigger. Okay, so we started with a divisor of 50,000. We're going to make the divisor bigger. We're going to go to 50,900. Now, how we got there could take some guesswork. You might have to do this a few times. So for this first one, I'm just giving you one that works. Notice that it is larger than 50,000. So my first attempt using the standard quota gave me a total that was too big. We make D bigger. 50,900 is bigger than 50,000. So let's see if this works. I'm going to divide each state's population by this new divisor. Okay, so I just filled those all in. Now, adding them up is going to give you a number that has no meaning, so I'm not going to bother doing that. Next step is to round up, do the modified upper quota. So I'm going to round each of these numbers up, and I get 33, 137, 4, 42, 14, and 20. And when I add them together, I get 250, which means I'm done. I got exactly 250. Okay, problems that you might see here. I would say look at state B. Their exact fair share is 138.72. And if we're trying to be fair, it would make sense, since you can't give out 0.72 of a seat, it would make sense that state B should get 138 or 139. Right? Because that 0.72, you can't give out that partial seat. So you either don't give them anything or you round it up and you give them the 139. But using Adams' method, they ended up with 137 seats. So they ended up with fewer seats than their lower quota. So their exact fair share was 138.72, but they only got 137 seats. So problem would be state B is mad, right? They did not get as many seats as they should by fairness. Next example, the Bandana Republic is a small country consisting of 4 states, A, B, C, and D. So let's just put those in. A, B, C, D, and then we'll have a total column. And their populations are 3,310,000, 2,670,000, 1,330,000, and 690,000. That adds up to 8 million. 8 million people. Okay, so these are the populations. And I'm supposed to be doing this, doing Hamilton's method. So this is the method from last class. So we'll start there. you always start with the standard divisor, which is the total population divided by the number of seats, which we are told is 160. All right, so that comes out to 50,000 people per seat. 50,000 people per seat. So we calculate the standard quotas next, which is exactly how many seats each country should get by giving them one seat for every 50,000 people. So we do 3,310,000 divided by 50,000, and that comes out to 66.2. All right, we go ahead and do this for each country. And when you add them up, we get exactly 160 seats. Okay, but you can't give out a partial seat. So this is Hamilton's method. And in Hamilton's method, we give everyone their lower quota to begin, which means round everything down. 66, 53, 26, and 13. And that adds up to 158 seats. So I have 2 more seats to give out as surplus. We give them out to the countries that have the largest decimal. So we have a 0.2, a 0.4, a 0.6, and a 0.8. So the largest would be 0.8, second largest is 0.6. I only have 2 seats to give out, so I'm going to give 1 here and 1 here, zeros to the other 2 surplus seats. So then my final apportionment you get by adding the lower quota to any surplus. So we have 66, 53, 27, 14, and that adds up to 160. So there's our final apportionment. For this next example, it's the same example as before. It's the same 4 countries, still 160 seats to apportion, but this time we're going to apportion them using Jefferson's method. So I copied down the first couple steps from Adam's method because they look the same to get started. You write down all the populations, you get the total, you just get the standard quotas by dividing each population by the standard divisor, which was 50,000. So we have the standard quotas. Now Jefferson's method says round everything down to a lower quota. So we have 66, 53, 26, and 13, and that adds up to 158. Now, 158 is too small, right? So in these modified divisor methods, when the total is too small, you make D smaller. Okay, so my original divisor, standard divisor, was 50,000. So I need to choose a new divisor that is smaller than 50,000. So the rule of thumb is to change your divisor by about 0.5% for every seat you are off. So we're off by 2 seats, right? We want to give 160, but we've only given 158. So we're off by 2 seats. We do 0.5% for each one. So that would be 1% total. So I want to make D smaller, my 50,000. I'm going to make that smaller by about 1%. So we calculate 1% of 50,000. Let me write this down here. 1% of 50,000 is 500. So I'm going to change D. I'm going to make it smaller by about 500. So my new divisor, my modified quotas using a divisor of, say, 49,500. It's smaller than D by about 1%. Okay, so now I divide each state's population, 3,310,000, divided by 49,500, and we get about 66.87. Do this for each of the states. And then adding those 4 numbers up does not give you anything meaningful, so I'm just going to put an X there. And then we round everything down. modified lower quotas, we get 66, 53, 26, and 13, which is exactly what we had before, 158. So we want to make D even smaller. You might be tempted to jump by another 500, but you know, that first 500 was 1%, and more likely we're just not quite there, right? So we needed all of these modified quotas, like 66.2 went down to 66, but so does 66.87. That's very close to being up at 67. 67 point something, so that would round down to 67. And 53.4 went to 53.94. That's really, really close to being a 54 point something and rounding down to 54. All of these decimals are really close to getting to the next number. So I'm not going to make D smaller by another 500, because if you look at how much it changed when I did 500 from 0.2 to 0.87, I might make it jump too much. I don't want all of these to jump. So I'm going to do a smaller D, but not by too much. I'm going to try getting modified quotas using D equals 49,350. Okay, so I'm just going to go down not by another 500, just by 150. And then I divide each state's population by this new divisor. And the first one gives me 67.07. Okay, so I have filled in all of these new modified quotas using the new standard divisor, 49,350. The sum of them is doesn't give you any information. Next step is to round them all down. So I get 67, 54, 26, and 13, and that adds up to 160. So we're done. It is entirely possible that it could have taken you 2 or 3 more attempts to come up with the 49,350 number. Finally, we're going to apportion the same countries' congressional seats, 160 of them. But this time we're going to use Adams' method. So I have the beginning set up here. It's the same as the beginning for Hamilton, Jefferson's method. But with Adams' method, our next step is going to be the upper quotas. We round everything up instead of down. So we have 67, 54, 27, and 14. And when we add those up, we get 162, which is too many. So we have to make D bigger. Okay, when the total is too big, make D bigger. So we have to get some modified quotas using a D that is a little bit bigger than the standard quota, which, remember, it used the standard divisor, which was 50,000. Okay, and the rule of thumb is to change by about 0.5% for each seat you are off. So we're off by 2 seats here, 2 too many. So 1% of 50,000 we already figured out was 500. So I'm going to go up by 500 because I need to make D bigger by that amount. So we'll go to 50,500 and see what happens. So I'm going to divide each state's population by 50,500 and put them in these blanks. Okay, I took care of that. The sum of the modified quotas doesn't give you useful information, so we won't bother adding that up. Now I'm going to round them all up. Modified upper quota. Adams' method, you always round up. So this gives me 66, 53, 27, and 14, and that adds up to 160. Done.